test this in the field and show what its effect is, quantify that. So set out this last year, and actually it's not really this last year, it's the last 4 years, or almost 5 years now, where I started breeding near isogenic lines, and I started moving that chromosomal inversion through breeding into the inland genetic background and into the coastal genetic background. And wanted to ask, okay, do these things have effects after I bring them into these different genetic backgrounds, and how does that inversion have effects out in the field? And so after the 3rd generation of backcrossing, and I went to the 4th generation backcrossing finally, you see effects already where you have the coastal parental, and then you have this near isogenic line that's homozygous for the coastal type of the inversion, and it flowers late. And then you have it where the inversion is moved in, and it flowers earlier. And the cool thing is I also noticed that there's some anthocyanin spots on these things. And so that locus actually maps to the inversion too. So I could actually visually see where the inversion was in which plant just based on the spotting pattern on there, and start to follow that through as well. And then I took these near isogenic lines and their parents, drove them out to California and planted them into both inland and coastal sites. So I've got about 1,800 plants at each site, 200 of each of the replicated inversion types, and as well as the parental types. And then you get some results. And so this right here is what I found before. So here I've just got the inland parents right here, which they do really well inland. They have really poor fitness at the coast. Coastal parents have bad, really poor fitness inland, really good fitness at the coast. Now if you look at a plant where this is a near isogenic line where I was moving the coastal type into the inland genetic background, but in the last generation I popped that out. So this thing is mostly inland. It has the inland type of the chromosomal inversion, and it does pretty well, but not as good as the inland parent. But if I have a type where I move just swapped in the inland or the coastal inversion type in blue, you have a significant drop in fitness, about a 20% decrease in fitness as a result. Now looking at the coastal genetic background, here you have a thing where it's got the coastal genetic background and the coastal allele for the inversion, and it does pretty poorly here. But if you put in the inland inversion type in that coastal genetic background, you do about 20% better here. So I'm seeing about the same percentage effect on fitness, and I think this is due to flowering time. I'll show that in the next few slides, in both genetic backgrounds. So here's that difference in fitness, and here's the parental difference. So you explain about 20% of that fitness difference based on that inversion type. And at the coastal site, you don't see as much difference based on the inversion type, but you definitely see this genetic background difference where you have the inland genetic background has this clear pattern here, coastal genetic background goes like that. And so we're explaining some of this difference, but it's obviously polygenic, and there's a lot of other loci that explain local adaptation overall. If you look at just survival to flowering across habitats, you see inland genetic background, they're pretty much all the same. Coastal genetic background is the same, except for the one that has the inland allele at the inversion, and you really shift flowering time survival based on just swapping in that inland allele. And here's to show that flowering time is really behind this at the inland field site. So this is just the inland field site. We have all the things with the inland genetic background. They go up, and we get almost 90% survival for all of them to flowering. And the things with the coastal genetic background, they have pretty poor survival to flowering because they come up and they flower later on. And then if you have that inland orientation swapped into the coastal genetic background, you get up to about 50% flowering survival before the drought sets in. It kills everything. So here's let's see, there it is. There's the drought when it sets in. And after that, you get pretty much leveling off of fitness. And everything dries out and everything dies at that point. What's neat, though, is that if you look at that coastal site, we didn't see big fitness differences based on flower production. But what we do see is that everything with the inland genetic background dies in that first season. All of it dies. With the coastal genetic background, and pretty much the same thing, except when we swap in that inland type of inversion, and we get really low survival to the second season. So about 69% of this parental divergence in survival to the second season is due to just swapping in the inversion there. So that suggests that there is a contribution of the inversion to perenniality, and that there may be fitness consequences in subsequent seasons there. And so we're really seeing this annual perennial trade-off. Life history transition may be mediated somewhat through this inversion.